So our group focuses on cloud, and Roman's group actually is pretty
display
across
or
the
it will
gamut, right?
display on the screen? I mean the
Wouldn't you
word
say?
or text.
Yeah, anything
Not
Google
clear.
related you can get from
Very
My
blurry.
only
So,
goal is
check
to
them
show
out.
this.
So, like
I'm
as
not
I
sure
mentioned, we have
about
two
that
different
one.
tracks going on. So in this room here, we have Amey and Nishtha who are going to be speaking about developing companies, talking about building multi-platform apps with Compose. And then we have Sierra, who's going to be speaking about watch this, building apps for wearables. In this room. Oh, let me go back. And then the cloud track is going to be in the Esplanade room just across the way. Marissa is going to be speaking about using Google Cloud for precision medicine. And then we have two generative AI talks, which Google's an excellent sponsor. And then today we have our sponsor Postmates. I don't know if all of you got the flyer that Roman was handing out. If you haven't gotten one, please connect with Roman during the break and make sure you got one.
Do not take a picture and send it to your friends. That's all I have to say. There's one per person.
Listen, we highly value our relationships with our sponsors, and Postmates has been incredibly generous to give everyone the ability to spend $25 in the next, there's some time window, Roman?
The 25th.
Okay, they have until the 25th, so this is incredibly generous of them, so please do not abuse this. We want to be able to offer these sort of things to our guests in the future. Okay. So that is the opening session. Those are the opening comments. What we're going to do is just quickly break so that folks who want to check out the cloud talks can move over into the other room there. And if you're planning to see the Android talks, you can stay in this room. And if you want to move around, feel free. I mean, the rooms are very close. So you can check out a little bit of one talk and then go to the other room if you wish. Please just take a few moments to get into the correct room, and then we'll be starting again very shortly. Yeah. Thank you. Hello, hello.
Oh, on the other side, I see. Okay. So
What happened?
It's not working right.
out the other side.
Yeah, in the room, but not for the people online.
Yeah.
Working right. So what we're doing
Is this? Did you want me to switch to this one? Is this one not working?
No, it's not that. These are both paired to this receiver.
Okay.
We think that this receiver is not getting it.
Android here is cloud there. Yeah, exactly.
Yeah.
So there's no sound in
This receiver, we think this is not getting in the bevy. And when we unmute the laptop, I think the laptop's getting in the bevy. Can you talk to Linda?
So we selected that's the microphone wireless go-to.
Okay.
That's
Okay.
and we selected that, and then we muted, and then when we unmute, they can hear us talking by the laptop.
It's picking it up right there.
Yeah, so it's coming through there and here. I'm not sure it's going.
When do you want to cut off walk-ins or plans?
Pretty soon. Yeah, at 5 was the official cutoff time. So what I was thinking is 10 people show up at 5, and those are the 10 people that get in, and then no one else. But 5 is.
When it's 5:30 before the session actually goes up.
We told people 5, so we can do it shortly after 5. We don't have to wait until 5:30. Yeah. So you don't think that we're getting the right audio into the session?
So right now, I think it's working.
Okay.
But I'm not sure, if it's this one or it's just going through the laptop.
It's not going through the laptop. It says the input, that we can trust that that's the input.
Okay, we can trust that then.
Yeah.
Okay.
If Linda's saying that she's not hearing it.
Everything's working correctly now?
Is it how loud is the audio?
So if you turn both of these mics off, it should go silent. Turn that off, please.
Yeah.
Okay, so now she can definitely hear all of us.
All of us.
But not the room.
No.
And then when we switch to the
One, two, test. How is it? 1, 2, 1, 2. This is where. Yeah, could you put this on next to the
Hi. Are you the speaker? Are you the speaker? Yeah.
Right over here?
Oh, yeah.
So the mic is over here is already on, so everything you're saying is already practiced.
And then there's two speakers for this session, right?
On the other side.
No,
Oh,
there's
oh,
two
from
speakers for this
Yeah.
session. Do we have
Oh,
two?
wow. Yeah, so this goes actually, sorry.
Yeah.
This goes to the first two speakers.
So I'm going to
He's
introduce
introducing the two speakers,
Then
and then I can
could
give
you like
yes.
hold it and then like
but we do have two. She's getting another. Okay, sorry. Good. That was
That was it.
okay.
We are about time.
5:01.
Yep, let's do it. Okay, showtime.
maybe give it to the female.
All right, folks. Showtime. All right, good evening, all. Welcome. I know that it would have been difficult for you to select between Android and cloud, but I'm glad that you joined Android track over cloud. I know that the cloud track would be equally good, but anyways, here we are. Well, Google I/O is all about learning the latest and greatest about Google developer ecosystems. And I/O Extended is about taking it a little bit forward, where we share all of that knowledge with the community. So I'm one of the co-organizers. I have a meetup which I share with my amazing organizer Beth over there. So I'm going to do a little bit promotion of my group. So I run this meetup called Boston Android. If you have not yet joined the group, then please make sure to join it. I see many familiar faces over here who have joined and enjoyed. They can vouch for it. It's an amazing group. We also have a Slack channel. It's pretty much, I would say, yeah, pretty much collaborative if we are not active, but we do our best in answering all of the questions from the community, pointing out to the latest resources, whatnot. We also have a social media presence on Twitter and Android. All of these talks would be live streamed in this particular channel. So let your friend and family know that they can watch over here, and they're going to be recorded and be available for later viewing as well. We are planning to run a compose camp starting from July 5th. And this is your opportunity to get started with the modern Android development skills if you have not already. Our friend Anton over there has been gracious enough to give us a space in Accenture office. We're going to run it for like 5 whole weeks, and it will be hosted by yours truly. So I'll see probably if you will do that. Alrighty. Right? It's going to be fun. Now, without further ado, let me introduce the amazing speakers who would be speaking right now. Amey, who is working for the government of University of Colorado for the digital services, I believe. And there's Nishtha, who used to work at one of the leading telecommunication platforms in India called Jio. They're going to talk about what it takes for developing communities. So let's give them a big hand.
So I can use this, right?
We have the info on the Android and Monday at the cafe and also virtually.
Start the timer.
So that everybody can see everybody.
And so this, I can show you hand gesture. No, like we can.
Hello. Yeah. So, how are you, everyone? I'm not able to hear anything. How are you? Great. That's it. So I'm Amey. I'm like the student of the Northeastern University doing the Masters of Information Systems, and I worked for 2 years back in India and like Android, in digital marketing, in blockchain, in a lot of domains. And later, I decided to pursue masters. So right now, I'm here at the Boston. Can you just yeah. So like apart from my background, like I'm also the Indian classical, like whenever I'm free, I'm also practicing the Indian classical vocal music, and I'm also a hobbyist poet. And till now, like I have worked on a couple of applications, a couple of websites, couple of products which are being used by millions of people worldwide. Next. Yeah. So first of all, here, like this talk is basically going to get focused on the developing economies like India, Bangladesh, Nepal, where there are no high-end devices, there are only budget devices. So right now, the first thing is what we should do. Like, let's say if your organization doesn't have budget, and let's say if you want to test it on other devices, is you can install the custom ROM. So custom ROM, like for those you don't who don't know, is just kind of layered Android operating system, which is built on the top of AOSP, that is Android open source project, which is provided by Google. And like developers make the customization to that version of Android. For example, let's say if I'm having a Samsung phone, and if I want to test the how my application will work on Xiaomi, then I cannot do that in normal way. So like I can change the operating system of the Samsung and put in the Xiaomi operating system, put in the Oppo operating system, put in the Techno or whatever the brands are there. And believe me, this if you apply like even this 2 to 3 custom ROMs, this is going to save you thousands of dollars. Plus, this is going to like potentially generate millions of dollars into the revenue, because like here in the US we have a couple of devices in Android, but let's say in developing economies like India we have like 500 devices. And again, it doesn't matter like whether you have money or not, but it's not possible to buy 500 devices every single year just to your office and test them manually. Second thing is study the market, as I told. So the devices are going to be the budget, though definitely like the Android Marshmallow or the Nougat or the Pi or 910, like they are getting outdated. But like we have seen a lot of old Android versions uh, in the developing economies like India. So third point is how to select a ROM. So to select a ROM, basically you go to XTL and use search for the highest selling device into your market. For example, in India, the highest selling devices like it was like under Xiaomi, like in Nepal it might be different. And just list out the custom ROMs over there. So in the XTA, like you can note down highest selling devices in your region. And second thing is most number of custom ROMs which are available for that devices. So this is how like you can pick the device and which custom ROM is the best. Titanium is just kind of the backup tool that we can get so that let's say while changing the ROM, if you decide to change the ROM from Samsung to Xiaomi or let's say from Oppo to Vivo, you do not have to install every single app every time. You can just onto that Titanium backup, and then you can install take the backup of your phone and install all of the application at once. And yeah, so like don't forget me to send you docs. Like I'm always open. Just me. Yeah, next. So thank you. So know your user. So first of all, when you test, let's say it doesn't matter in the test lab or the AVD or in the physical device, no one runs like there is not a single user who is running a single app of yours. The user like because in our case we have observed the user has typically 50 to 60 applications at one running at once on phone, and like a lot of applications in a lot of job schedulers, but that means a lot of background services, a lot of broadcast receivers, like a lot of computation is going on. So basically make sure that you like if it's possible, then like in our case we actually used to have like being a security application, we used to get the data of the all of the applications from the user with the user's consent, so that we know how which applications users are using, so that we will actually get to know. For example, our app may not be compatible with app A, may not be compatible with the app B may not be compatible with the app C. There might be some kind of notification conflicts, or there, let's say, if someone else's some app other app is using floating notification window permission, and we are not able to use it. So there are a lot of things that you will be able to determine when you actually study those metrics. Then background activities, as I told, is like a lot of apart from your app, a lot of background services are going on. And yeah, in developing economies, the SaaS model, like so if you decide to sell software as a service, or let's say if you decide to actually have a premium or freemium model, it's a low probability that it's not gonna work. We have tried, and then for developing economies, like right now, like Google is doing pretty good, but yeah, like what I would like I would stick with the free and the ad based model. And yeah, so using this data accurately is very important. So like whenever, let's say, if you see the crashes, let's say the issue reproduction is very important. So like in your Play Store console or in the Firebase crash analytics, you will see a lot of crashes and all those things. So by using of the custom ROMs and all of those things, you can actually end up reproducing those bugs and reproducing those issues so that it will be easier for you to fix them. Yeah, so this is the QR code that you can scan. This is what like we have struggled in India. As I told, like in India, there are a lot of brands, Oppo, Vivo, like Mango, like, a lot of other brands are there. But the problem is, let's say if you want a simple add to start permission, then Android intent won't work. You actually have to write the custom intents of like it might be the floating window, it might be the auto start, it might be the battery optimization permission, any number of permission, or the special like anything like any kind of permission, because all of those layered Android devices, they have their own set of tools and own set of security centers. You actually have to open them, because let's say uh, like some OS is not allowing you to start the app in AutoStart, and though you are having the Android AutoStart permission, it's not used. So like this link is very helpful. Like yeah, heat is bad. Yeah. Yeah, like in Boston, so this is my first time in the US, and it's pretty cold, and now I'm getting used to it. And in the summer also, like I'm feeling hello, it's winter, because we are not so used to it. But in like in India, like there is a lot of heat, like it's room temperature is high and the device get heat up. So what happens is they will end up becoming slow. So you have to take care from the user point of view. Like, let's say if it's possible to do the actual one-to-one user survey, then you can ask the users, you can meet the users. Let's say like one of the application MDM, that's mobile device management that we're working on, is a tracking salesperson. So we actually had to discuss the salesperson, because like salesperson were roaming around in the heat, and they were traveling via bike. Then due to the heat, their mobile used to get like more heated, and plus our application were running background continuously. So again, studying the user matters. Avoid the loops. Again, all of the practical data structures and algorithms like, that we can use. Floating point calculation, like better to keep in integer, like and like remove all the floating point calculations. Less animation. Yeah, I will not name the libraries. There are amazing and super animation libraries. Again, just imagine you have put 1 month with your developer and your Adobe After Effects designer just to get a single animation of 15 seconds. And let's say if it gets installed to the user device, it's getting crashed or it's getting lagged. It's not good. So it's better to avoid. It's better to use less animations as possible. And again, data structures and algorithm. If you use the efficient data structures, especially for the mobile development, and if you do it in a scale, you will definitely see the improvement in the time. Run on UI thread, yeah. Those who are familiar with the Java and the Android coding, like it's very good. So like I used to just write the raw code. Like I used to go to Stack Overflow, copy the code, paste it over there, and then again run it every time if the app opens. But the problem with this is, even if you kill the app from the background and you open the app again, like from the scratch, the thread will keep running. The thread will not get closed. So it's better to close the threads manually. Like what is run on UI thread, it's just an example, like with whatever threads or that you will be using. Fall in love with Kotlin, yeah, yes. In 3 weeks ago, I had an interview in the, I will not just name the company, in the Boston, who are still using the Java, and the company is amazing. They are working on really good product, but still they are like using the Java just for the fear, oh, what if we don't get that support? What if we don't get like that kind of structure? But believe me, you do not have to migrate your entire code base at once, but I highly recommend you to start at least migrating the modules. As the code is like interoperable, like you can work with the Java and anything you want. But like let's say if you want to decide the new functionalities in the app, it's better to use Kotlin, no than exceptions. Yeah. Again, preparing for the internet failure. Yeah, everyone knows the game in that room, and so again, you can gamify some 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 part of your applications. Again, they hate rotating circles. So like previously, it was like async task. Like later, they migrate. But the problem is like it's better to get it done simultaneously in the background service so that you have something user will not get stuck. And let's say in India, we don't know like where the user is and what's the bandwidth of the user. Like in developing economies, user may cut off with the internet. Like I have seen the apps of popular brands getting crashed into the trains or getting crashed into the forest because there is no network in spite of like using all of those standards. So you really have to like, for example, let's say even like writing simple download manager, it's better to test with the Android profiler. So like in the last workshop, Sagar has really showed the best demo of the Android profiler. That's really great tool that you can actually use to measure the performance, network, and everything. And yeah, Firebase real-time database. Like I'm very big fan of it. Uh, I'm not getting biased, but again, this is very important because again, it's on device also, it will get synced with the cloud real time. Use of SMS. So again, internet is the kind of option you can consider, but what you can do is we used to have some kind of features which were SMS based. For example, like then having worked on the security application, let's say if your mobile gets stolen and if your mobile doesn't have the internet connection, what you're gonna do? So what like we had a functionality where like we have a specified this number. If the device gets the SMS from that number, the device will get formatted. So whoever the thief is, whoever the person who has stolen the device, that person will not have any kind of access. Why we had to do with that because internet is not capable. Again, like fall in love with Kotlin. So like there are a lot of things because like the code base reduces. You will see the memory and the RAM management is really good. And yeah, so focus on offline things that I just explained. Next. Yeah. So the basic thing is like whenever you are, let's say, like I hope like everyone is doing lead code and like most of the here are students or let's say if you are giving interviews in the other companies. So what I even like I'm not the best coder in the like in the even I don't like it's the basic problem. But what I used to do is let's say if I'm learning hash map, then how I can use the hash map in the Android. Let's say how I can replace let's say the redundancy. How can I remove this with the data structure? Just for the practice. Like if you keep doing that, the because like when I interacted with a lot of the people, they are not able to crack the interview. They are not able to crack the technical interviews. So if you keep applying the knowledge on your level in the application or in your domain, it will definitely help you to build the logic. And this is the kind of secret of building the efficient application because like again like here we have 8 gigabytes, 12 gigabytes of RAM and Snapdragon like 900,000 like I don't know the best version of the processor, but there you have to take care of the efficiency. And yeah, so mobile development motivation in the job market. That's also the point that I want to highlight. Is again, like the market is bad, everyone is accepting like it's okay. But what I see is whatever I'm building, whatever I'm working on, are there people which are using that technology? Let's say if I see, yeah, there are people I'm working on Android. Doesn't matter if I have a job or not, but I always have something side project going on. So this is especially for students. Doesn't matter if you are making money from that project or not. Doesn't matter if you're getting job or not. Doesn't matter like uh, if you are getting paid. What matters is if you like the technology and if there is user base, you should go for it. So like you should be relaxed. Like okay, there are people using it, so I don't have to worry about it. Like someone will hire me today or tomorrow, or I can start freelancing or whatever it is. So next. Yeah, so again, you cannot make a person better without the best leader. So I'm just kind of a face value over here. So like I'm not a single person actually. So like again, thanks to all of my leaders, my mom and dad, my even the musical guru, my Android guru, my ex co-founders, my friends, like the grateful leaders I had because of them I used to experiment a lot and here also like I have got a chance to meet a lot of amazing people over here like in the GDG Boston or even a lot of Google developers but they are very supportive. I'm very thankful to all of them and thanks a lot to you. So before moving forward, so Nishtha, I would like to know like have you worked on the Android team?
Yes, I have.
Okay. So the main problem with the Android TV is it's not just like get the code and just whatever that I told on the mobile cannot be applicable on the TV. Like we had a conversation with Nishtha. Okay, I have to have this like presentation about the TV because right now what the Geo is doing or the telecom industry is doing in India, they are actually the TV is exponentially increasing, and like I would love to share the light on that. Yeah.
Thanks a lot, Amey. So, as Amey said, that I have worked on Android TV applications for one of the biggest telecom companies in India, Reliance Jio. And so they have started actually developing apps for their set-top box, and it was a really great opportunity for me to go ahead and develop apps for them. So let's move forward. So something about me is like I'm currently a grad student at Northeastern, and I have been a developer for 1.5 years. And I've developed for both mobile and TV, and also a beginner level expertise in Flutter. Apart from technical things, I really love gaming, reading, and I socialize a lot with my friends. Now, a bit of introduction to Android TV. So, I would say the uh, GLF, what you see over there, it's like it for Android TV when we develop, it is similar to that. So as soon as I give the app to my developers, my testers, they come back with me. They come back to me with all of the bugs that they have, and those bugs are normally with respect to different TV sizes. Like we have very different TV sizes. So with respect to that, there are lots of and lots of issues. Uh, and then let's go to Android X TV. So these are a set of libraries and APIs specifically designed to simplify Android TV development. And they are part of Android Jetpack Suite, which provides us, the developers, with a set of tools and components for building high quality Android applications. And then lean back UI paradigm. This is a user interface design approach developed by Google for TV and other high speed devices. Uh, it is based on the principle of simplicity and intuitive navigation for a more engaging and enjoyable user experience. So now let's take a deep dive into some of the topics related to Android TV development. Uh, One of them is the leanback library. So it consists of a range of UI components designed specifically for the TV apps. Some of the components are browser fragment, header fragment, and detail fragment. So the image which you see below the leanback library, the red part of that image is the browser fragment, which basically gives you all the headers. And with respect to each of the headers, you can see the detailed fragment on the right part. And we can build consistent and intuitive user interfaces that provide seamless navigation and content discovery experiences. I personally face a lot of issues with the library when I first started developing for the TV apps. And this was mainly because for mobile development is very easier and you have lots of resources. But when I started, it was very hard for me to get like a bunch of resources for this. So I hope for in the near future, everyone does not use the same. Maybe I can help with this as well. And next we have some TV specific UI considerations. So these are some of the considerations what we normally take with respect to TV legibility and larger text sizes. So that because in TV we actually read from a very far distance, right? So that is one of the main things that a developer should keep in mind. Then we have focus indicators and appropriate UI elements. Then we need to prioritize legibility, clear focus indicators, and some TV specific input handling. So even when a user is entering something for searching, so proper indicators for input should be given, and the app should look really well, and it should perform well on TV screens. let's go to TV navigation. So for that, it can be more complex than traditional mobile navigation due to the unique input mechanisms and focus-based interactions. Now, designing effective TV navigation requires careful attention to the focus management, focus traversal, user actions, and accessibility considerations. So, by creating the intuitive and user-friendly navigation experiences, the TV application experience for any user would be very good. And then let's move on to testing and debugging. The proper testing strategies include device compatibility testing, automated testing, attention to UI consistency, and addressing TV specific issues. So that the developers can actually create robust and user friendly TV apps. Now, supporting multi-screen sizes by considering some of the factors like layout, responsiveness, grid-based design, focus and navigation, text size, and legibility and quality assurance. So, we need to pay a lot of attention to the corner cases for edge alignment and many different things. So, as you can see, the smart TV on the left side and the Android TVs on the right side, there are differences in the UI. And this is because some of the apps and the whole of the OSs are a bit similar, but developers always think that all their applications and layouts should be very different. So we kind of try to make it as easier and as beautiful as possible, but sometimes we cannot do that as well because of many reasons. Uh, Next, we go on to the deep dive into some of the other widgets and lean back libraries that we have. So some of them are lean back widgets. Now these libraries include a set of UI widgets which are designed for TV apps. It offers specific versions of common Android widgets like the image card view or the list view what you see and guided step fragment. So guided step fragment is something like if you have a settings page. Now, if you choose one of the options, next you want to go into the next step of that particular option. And so we have a guided step fragment, which is similar to what we have in Android mobile application as well. Now, next, lean back preferences. This library offers an extension to the Android X preference library, specifically tailored for TV apps, and it provides TV-friendly preferences and setting screens optimized for the lean back user interface. And these normally use the remote and the keypad for navigation as we use for the TVs. And then we have the lean back transition. This library provides support for shared transition in the TV app. And it allows smooth and visually pleasing transitions between different screens and elements within the app, enhancing the overall user experience for a user. Now, the lean back player type, it actually offers player interfaces. Sorry. It facilitates the video playback in Android TV and it offers a player interface and classes for managing video playback and including support for the adaptive streaming, media controls, and the playback customization. The Leanback player library integrates well with other Leanback components, providing a seamless video playback experience for you. And I think I'm done with the presentation. Thanks a lot, all of you. Does anyone have any questions for us?
Question. So I think in the initial slides you talk about the custom ROM.
Yeah.
Now, when I was in college, back in like 2012 and 2013, India was like huge into custom ROMs. And I feel like partly because the vanilla flavor of Android was not Thank you. Yeah, it was not there yet. How about now? Like, do you feel like I don't remember the name of those custom ROMs. I feel like it was called Lineage OS or something. Is there still a popularity back in India or in other European countries? Or do you feel like vanilla Android has achieved all of those shortcomings like battery optimizations and whatnot?
Just wait, let me plug in the speaker. Yeah, that is a really good question. So right now, what's happening? By the way, I have tested more than 100 plus devices and 500 plus custom ROMs. So like, just name the ROM. It's not better than that. Right now, like definitely, it was like necessity is the mother of invention. That is the phrase that I used. So definitely, the market was huge then, and right now also it's getting like a way better. So like the ROM that you have just told, it's Lineage OS, which originated from the CyanogenMod. And like for that, you need to unlock the blue bootloader of the device. And can you just repeat the last part of the question?
Yeah, I was wondering, like, do you think Android has achieved all of those shortcomings like battery optimization and other things? Because I remember, like, in particular, CyanogenMod used to provide tons of like kernel level improvements which improve battery life.
Yeah, so let's say it depends on the use case to use case. So let's say I'm a normal user and I don't want, if I'm having a fair device, I don't need to use the custom ROM technically. But let's say if I'm using some kind of layered OS, I will not name those OS. And again, that they are eating a lot my battery life, and they are eating like making my phone slow. They are making me install some hardware, spyware, or like let's say adware, a lot of ads. So definitely in that case, because like right now the ROMs are they gone beyond the performance. Performance is okay. Like we are at least I think like we are over there. We are getting good performance on the vanilla, but what about the let's say if I buy the phone of brand X and if I let's say use it for 2 years, it's gonna get laggy. It's gonna be damn slow, and it doesn't happen with vanilla. Vanilla, like definitely Google is doing like great job like by providing the updates and all. Because like I have like 6, 7 years old year phone and like I'm running the Android 13 on that custom vanilla OS. But let's say if I decide to switch to the layered original manufacturer ROM, that is like in Android, they're giving me Android 11, something like that, and that's also like a lot of block. So definitely, this yeah, when the custom ROM battle will end is or when the layered Android, like the performance of the layered Android ROMs and the customizations that we get with the vanilla Android ROM will match. So because let's say if you want stock devices, then definitely the price point is very high. And let's say if I buy the same device at the same price point, I get highest specs as compared to Google. So if we combine both like vanilla and plus high end hardware, then the problem is going to get solved. Otherwise, like I don't think there will be the depth of the custom ROMs, or don't think there will be the stoppage on the development of the custom ROMs.
Yeah, makes sense.
Hey, Amey, thank you so much for the session. But yeah, when you said that like necessity is the mother of all invention, I remember the Indian word for that, jugaad, like which, yeah, like you reminded me of the days when I used to like set up the custom rooms, etc. But yeah, that's like the long story. So like I have two questions. First of all, like as we have tried like several custom OS, like I have tried like many different OS, like especially on the Android devices, which I have been like using so far. But could you like throw some light on the phone breaking? That's like the main issues which I have been facing. I used to face it earlier, like nowadays I'm phone breaking. But like, is there any way when we are trying custom ROMs, if we could detect any kind of phone breaking related issues and how we could null and void that?
That is really good question, Nikunj. I'm glad you asked. And yeah, let's say if anyone wants to have like anything from Google or like other companies, if they want to have a session on custom ROM, like we can have a completed like 4 weeks workshop on the custom ROM. But like I can show you like regarding breaking, how to unbreak, how not to break, and everything else. But to answer this question, first of all, like, do you know what does the breaking mean? I just want to get the idea of the audience. So do you know what the breaking? What does the breaking means? Okay. So the brick means, yeah. So there are two types of brick. I will not go deep into the technical. Earlier it used to happen is like your phone is brick. That means, yeah, you will actually see the pictures of the bricks in the phone, and you will not be able to do anything with the phone. You will not be able to power it on, or you will not be able to navigate. So that's all. Right now, what is happening is, like, if your phone gets into the boot loop mode, then it's called as breaking. So to avoid that, I would highly recommend you to, so when you unlock the bootloader, after unlocking the bootloader, if you are inserting the firmware, make sure you always have the updated firmware. If you have the outdated firmware and then you install the updated ROM, then definitely it's going to break your devices. But fortunately, the trends in the recent devices are, I have seen is soft. Like, most of the devices get soft breaks. So, like, if you go to service center, they can actually unbreak it, or you can unbreak it on your own by installing that uh, normal default ROM.
Thank you.
Ooh, I could definitely feel my gears turning, like Android TV and custom ROM. Good job, guys. All right. Our next speaker has driven all the way from the city that never sleeps. Please welcome Mohit on the stage.
Yeah. Yeah. Oh, I'll use that.
You're gonna use the peacock?
Yeah.
All right. It's all good. It's still live. Should be fine.
Oh, wait. So, you can press that. That will join event. Perfect. Okay, and do you see? Click on stages. Yeah, Boston Common. Perfect. There should be an option for presenting. I don't see it. Okay.
So this is right. So I can't join the virtual because of my ticket. Let's get Linda. I think we have to be able to So GDP. I want the community site. I'm going to do the demo. The demo. You should be hearing
Oh, is it because I'm not marked as a speaker when I got the ticket, or?
No. No. So, this is the demo shot. I did the. See, I'm not quite sure how. Oh, I'm not quite sure how to enable the backstage mic. So she's online here. Is this the link that's the link that I sent you, right?
Yeah, yeah.
Okay, so
5501, yep.
I'm gonna send it to you on Twitter. Right. Just to be complicated.
No problem.
Freaking weird. Oh. Okay. So now I sent it again. So Backstage Live. We want to. It's recording Backstage Live. You are now a presenter. All right.
Thank you.
That works with me.
Yeah, thank you. Do I allow, right? Okay. So how do I get to show up there? Or, sure. Oh wait.
Apologies for the delay, guys. We were figuring out a few of the technical difficulties, but now.
Oh wait. So here, I. Thank you.
We're good now, right?
Hello. 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 Hi. My presentation is on building multi-platform apps with Compose. My name is Mohit, GD in Kotlin and Android. First, thank you for the opportunity to present in Boston. So what I'm going to present on is how do you use Compose multi-platform? How do you structure a project? What are some examples of sharing like a UI between multiple platforms, and how do you go about doing that? I'll share like on iOS, like how do you like use a Compose, a shared Compose UI view like on iOS? What's inside of Swift UI? Like how do you hook it in? And we'll talk lastly about architecture and navigation. So before I start, I want to ask how many people use Compose? 4 people. How many people use Flutter? 1 people. Okay. Oh, sure.
Sharing another application window. How about entire screen if you do? How about try entire screen? I think for some reason.
No. It's not coming up. Oh, there you go. Wait, could you make sure? All right, that's technical difficulties are good because they make you get used to it. So yeah, how many people are Android developers? That's great. Everyone. How many people use Kotlin multi-platform? That's not surprising. So Kotlin multi-platform is a library for those of you who haven't used it that allows you to build, allows you to share code between multiple platforms. So when you work for a company, there's usually a team of people, of iOS engineers, Android engineers, building features in their respective platforms. But what you want to avoid is duplication of logic. And Kotlin multi-platform allows you to share like your business logic among these different platforms. So when you look at different platforms, what are the things that you could share? You could share like your code that interacts with the API, your repository and data layer. You could share your caching layer, and in the ecosystem, there are many different libraries, Ktor and SQLite, that allow you to easily, write shareable, data layer code. So definitely, you can do your business logic, like calculations you're doing. Now you're able to share UI components. You could write UI components in the shared library, and it's going to be, then you could use it on Android and iOS. And that's what I want to show you. So this is the library. It was announced at CollinConf. At CollinConf, they announced alpha support for iOS. And at Compose, this is JetBrains Compose multi-platform library. For Android support, it internally uses Jetpack Compose. And I'll share with you what does it use for iOS to get it working on iOS, to render on iOS. So one caveat is that this is experimental, so anything, there will be a lot of open questions, but that's good because that's how we progress forward. So there are different approaches you could take that I thought of. One approach is that you could share individual UI components, not your whole UI. You could share what you find to be valuable. But that in itself also, opens up a lot of questions. What about theming? What about if you're trying to share something that's part of your design system? How do you go about like organizing your code, etc.? So on Android and iOS, suppose you had multiple UI components and written in Kotlin and Swift, and you could share them in Kotlin in this shared library. Another approach you could take, which is you'll see, by the way, you'll see in their repo examples of both of these approaches. There's one example where everything is written, the whole app is written in Kotlin. The UI is all written in Compose. That in itself is also, it raises a lot of questions because that also, I will share with you the questions it raises. So what I did, it's good to learn about new tech by building personal projects. And one of the projects I worked on personally was to learn Swift UI. I built a simple app that displays a list of images and just displays some details. And the purpose of it was to learn Swift UI. And what I worked on was converting this to Compose multi-platform. So the first thing I thought about is how do you go about structuring your UI? So when you look at Android examples, they will structure the UI by having like a root composable method and then everything else, and then it calls like other screens. How do you do that? So when you create a multi-platform project, you have multiple apps. You have an Android app, iOS app, desktop app, and then you have a shared library. And the shared is a great module. It creates an artifact that you can consume on Android app, a jar file. An iOS app, it's an Objective-C framework that you could consume, and they add annotations to make the code, more friendlier on when you consume it and stuff. And that's good. So all right, thank you. So that was good. That was another tech problem. What was I? Yeah, so you have in your share folder, you have different source sets where you could add code to your common code, but you could also add specific bindings for Android and iOS. So first thing you want to do is that they provide a plugin, which really provides helper utilities that makes it easier to configure things. And they provide to you this common libraries that you could add. So they have a material, for example, artifact. So they have material support for multiple platforms. So first thing that you want to do to be able to build a scaffolding that your Android and iOS app would use, for example, a root app root view, like a root composable function, is to you could declare that in your common source set. And this is a composable function. For those of you who don't use compose, this is think of it. So all of your UI components, they're composable functions. You could think of them as the atoms of building a UI in Compose. And so there's a library called Compose UI, which provides you with like task lists, the way to do that. Compose itself is not just about UI, it's a library that knows how to manage a tree of nodes, for example. And you could extend that in the UI space for UI or for other examples. So this is a composable function, entity with composable. And over here, I'm going to specify scaffolding for my app, where the content will go, and where the top bar and items are going to go. So this right here, I put this in the common shared module that I'm going to utilize from Android and iOS. And I could also share an app theme. So when you create the sample project like on Android, this is in your Android app, so you can move that over to your common module, your common source set. So I have my color palette, and I have a wrapper for my theme, in which I'm selecting either a dark mode or a light mode. So material theme is supported, as you saw during the dependency we brought in. So then on Android, what I'm going to do is specify an image app theme like this, wrap my root view. So I'm going to utilize this in my Android app. And then in my Android app, I could call set content and utilize this method in Android. So my iOS app is where things get interesting. And this is Swift code. And this is a struct. And in here, I'm specifying a body. And then I'm going to create a content view, which is going to be another struct. And in there is where I'm going to utilize my, that app root view, the compose UI view that I specified in my shareable code. When you look at this content view, you see a Z stack, which is similar to like a lazy vertical list compose. And over here, just attach, I could, add in my compose view for it, and it provides utility. The JetBrains Compose Multiplatform library provides utilities to create a UI view controller. So, in this land, you have to create, the view controllers, and that's what I understand. So over here, the benefit of doing this is that in this layout, I could have other things in there. I could have other styling that I could specify on the Z stack. And that's one benefit to be able to add in right there in an existing Swift UI, like a view from your shared library. So that's what I'm going to do, is that I'm going to add in this list view with all the images from my shared component library. So what I'm going to create here is a struct, which is going to create a UI view controller. And the method that I'm calling here is underscore IOSPT dot. You could make that a friendlier name, but what that does is that it creates a UI view controller. And the way it works is that it uses this utility that the multi-platform library provides from JetBrains called Compose UI View Controller. And over here, I'm passing it in what my shared view is, which is the one that I created called Images App Common. So underneath the hood, that's going to set up create a UI view controller that's able to interact with that content. And then I'm going to just add it in. So the question now becomes, if you in Xcode open this up, you go to the view, you want to look at view hierarchy. How does it look? Out of curiosity. So the view hierarchy looks something like this. The multi-platform library handles creating window management for iOS, Android, and for desktop. And the key thing to here is that when you look at the last view that it attached in the view hierarchy, it's called Sequel UI view. But what's the Sequel UI view? So Seco UI view, Seco is a library. And what it is that it's a multi-platform binding for Skia. Skia is a rendering library, and it knows how to draw primitive shapes like lines, circles. So if I create a composed view, and like for example, it's a lazy list, it will figure out how to render that. And underneath the hood, it uses this library, which are bindings to it, to be able to figure out how to render your screen. And that's what the Skia UI view does. So that's important to know there. And so that's a very simple example of utilizing like a Kotlin composed view on iOS. So the other part that I want to now talk about is that's the easy part. But then when I was building this library, I thought about how do I display these images, and which is a very common, easy challenge. We all work on apps that have media visual things. And in the Android world, there are a couple of libraries that are available that all of us use, Coral, Picasso, Glide. And one challenge is that none of these libraries have Kotlin multi-platform support. But there are also libraries that people don't know about that have a lot of stars, but the main players, they don't have Kotlin multi-platform support. But in Coil, there is an issue open, and there is in the next milestone, Coil 3, where they're looking to add Kotlin multi-platform support. And that makes it easy. And there is a plan possibly integrating this inside of the JetBrains Kotlin multi-platform library. So this is good news. So one of the things I thought about is that in my app, I want to display a list of resources locally. How do I do that? And the examples provide a good example of this. So the Compose multi-platform library provides utilities for interacting with local resources. And what I created is an image provider that provides a bitmap based on URL. Now, in reality, in production, you wouldn't want to do this, obviously. But what I want to provide is an example of how to use actual and expect operations. It's a good example of that. So how do you do this? So here I'm utilizing that utility called resources, takes in a URL, and I need to convert these bytes into a bitmap. How do I do that? In order to do that, they're different, and iOS is different, on Android is different. So to implement this extension, I could even expect an actual declarations, and that's where the power comes in with multi-platform. In common main, I could specify an expect declaration like this. I'm not adding in the implementation here. I'm going to say, I'm kind of building a contract that you have to specify the implementation for this for Android and iOS, the implementation of this method. And when I go to Android main, I'm going to do actual fun. So the keyword is actual when you're actually providing an implementation. And then I'm going to call in this method extension called toAndroid bitmap, and bitmap factory is an Android dependency that I'm utilizing here. So what about iOS? So on iOS, I could use Skia utilities that are provided by this library. So on iOS, I'm going to do actual fun, and I'm going to add this to the iOS source set. And I'm going to do image make from encoded to compose image bit. These are utilities that this library provides, native utilities that you could utilize. So what I've done there is to provide an implementation using expect and actual for Android and iOS. And my provider could now recognize and call the method. That does look ugly, and ugly is good when you start off. So when how do you call that method? And there's another ugly way to do that. So over here, I'm creating a composable function to create my images list, passing in images. Let's not worry about whether that's stable or not. So the so over here, I'm creating a column of a lazy vertical grid 3. And I'm creating them, I'm going to call splash image method with image data. How is that implemented? I'm going to use a locale provider. One should be very careful of that because you don't want to use that for VI. And but that's okay. So over here, I'm pulling the image provider here, and this is just an example. So I'm over here, I'm creating this image bitmap mutable state. And I won't go into remember, but remember means something if you in compose, very important. Then I'm going to do a side effect to say that, hey, image provider, give me an image bitmap. Here's the URL for it. It gives me an image bitmap, and then I'm just going to give it to the image composable to render it. And that's just a simple example of being able to you could use expect and actual also with composable functions. That's also one thing to note. That's powerful. So the other thing to note here, so I could build this app and I could share the root view, the images list view, and the images details view. And the other thing becomes, how do you do UI architecture and navigation in between these screens? So there are different types of architectures everyone uses. Some people use MVVM or MVP. So suppose I want to set up the classical view model architecture. View model talks to the proposed UI. You pass in some UI state, and it passes events up to the view model. Well, how do you implement this? It's easy to implement this on Android because they provide you with lifecycle aware components. But then it becomes on Android. You could attempt to create your view models. But that also opens up questions because they're not going to be lifecycle aware. You're going to have to make them lifecycle aware somehow. That's foreshadowing hinted. So how do you do that? So I'm going to attempt to create a view model the nastiest way possible. I'm going to create a view model in the common source set. To create a view model, you need a UI state. You got a loading state, a success state, and an error state. Pretty simple. We could debate whether this should be a sealed interface, but I like debates. And so we could create a view model. We're going to create a view model and do the worst thing possible, create a scope. Why is that the worst thing possible? Because you have to manage canceling that. You're going to have to manage that yourself. And there is a very important concept of structured concurrency that you want to uphold to, you want to follow, to write reliable tests. That's why it's not good. So then I'm going to create a state flow with a default loading state. And then in that method, I'm going to launch a coroutine. And what I liked about this slide was that animation. So what I'm going to do is launch a coroutine. I'm going to tell a repo, give me the images list, and I'm going to push it to the success state and error state. It looks pretty simple. This handles the simplest case, but then it doesn't handle all the things that the Android view model provides you. You have to write that and hook up that yourself. And that's a challenge. And who wants to do that? I don't want to do that. So you could utilize this by collect that state from your view model and give it to your images list screen. And then pass in your UI state. So the other thing you could do is that you could create a list screen. And as you know, the patterns use that each screen has a composable function that takes the UI state, and you are having a loading state, an error state, or a success state. And now the question becomes, when you have all of this, how do you navigate? How do you navigate from lists? How do you navigate details if you're not using the navigation library that Android provides? And that's also a problem. And that also requires for you to build some scaffolding around that. So you could build a screens object as a common pattern with list with details, and then I could create a mutable state. What screen list I want to navigate to. Suppose the person clicks on an item, list item, I'm going to update this state, and I'm going to have a when that basically shows different items, pushes the different items in the content. I'm going to have a list, I'm going to have the details, and whenever someone clicks on the list item, on click, you just fires the event upward, and then I'm going to do some action update that state. Things that all of you know. So this is everything inside of that shared library that I have. So the problem is that these are not lifecycle aware components, and navigation is not simple because this is simple, but a real navigation library has to manage back, and then that gets interesting when you're doing it by yourself. And so there is a library. One option you could use, there's a library called Decompose, which is a popular library. And we'll show you how it attempts to solve that problem by providing an abstraction and handling the scaffolding logic of managing the backstack. It attempts to provide you with lifecycle aware components. So how would you utilize this? So, and by the way, in the examples, they also utilize this in one of their examples, library. It's a good library. So how do you utilize this? Well, this has a concept of a list component. What is a list component? It's the same thing as like a view model, and it has some arbitrary state, UI state that you could plug in, and then you have a class that you can specify. I'm specifying my UI state class as before. And when an image is clicked, I'm specifying some action, what actions I want to take on that component. So the way you do it is that you create a concrete implementation of that list component where I'm passing in a component context, and I'm overriding what my UI state will be. And also providing basically an action in there. And the way you utilize this in images list, and by the way, this underneath the hood handles the coroutine support for it. And it has support for multiple coroutine libraries. There's one with, I think it's called reactive, with a K. So I'm going to create an images list component right here, get the UI state, and then I could populate it using my one statement that I showed you before. So how do you handle navigation with this from one component to another? So you declare a root component. And over here is where you declare your stack. What's going to be in your stack? Some child, all of the child screens. Then you do creating a of them here, list and my details. So when I navigate, on Android, when you look at the examples, everyone creates a app navigator, right? And what's the equivalent of that? So I'm going to, over here, initialize a stack and specify what's going to be the initial screen in that stack. What's going to be initially shown. And I can use this navigator right there, navigation class to go from list to details. I can pass in a configuration to one to another. So if I wanted to navigate, for example, from my list component to my details, I could do navigation.push, and it also has support for animations. And I could pass in information from one to the other. And it handles the backstack management for you. So this, and if I also wanted to navigate back, I can just do pop. And all my navigation is in this default root component. So that's how you handle navigation. It's a very good library that you should try out. And those are lifecycle aware components. And this works on iOS, this multi-platform. So the other thing is that in my images app common, before I was creating over here I'm creating a list content, a details content. for each of my different screens. And on Android, the way you utilize this is to create a default root component. So this has bindings for Android. Then I'm just going to pass that into my images app root layer, images app component, composable method. On iOS, you could update your app delegate, which is equivalent to an application like class in Android, and create a root holder. Then you could pass in that root holder to your compose view. So it knows how to create that, that root view, the navigator from this. So that's a simple way of setting up navigation. So Decompose is a great library that handles lifecycle aware components. It handles like destroying them and handles cleaning up and backstack management. So I hope that presentation was useful for you trying this out. We hope you try it out yourself on your projects. And that's about it. Thank you. Anyone have any questions? I have some questions.
In your experience, have you found any drawbacks with multi-platform yet?
So one time I worked on a project where I attempted to build a library, and it was an A/B testing library that has a common API, right? And it was supposed to be used both on Android and iOS. So the Android repo is in a separate repo. It's a separate setup. And there are a lot of questions that arose. One is that first is what's going to be the API? How is going to be friendly, Swift idiomatic, right? And that becomes a challenge. And there are a lot of people have given talks on how to build idiomatic APIs. And the question becomes is that when this shared library is in a separate repo, it produces an artifact, which is an Objective-C framework. How will the iOS app consume it? So the iOS app, for example, was using CocoaPods. And how is that going to handle? So there are utilities that are given, but how do you then, you have to then set up this pipeline where that's got to go to Artifactory, for example, or some shared service. It has to pull basically from it continuously whenever it updates. Setting up that scaffolding was also a challenge. It's part of the work, right? Of building a multi-platform library, building also the tooling around it, and so those are some of the challenges.
Thank you. Great presentation, by the way. So I do Flutter, and we know how, let's say, a framework like Flutter achieves cohesive UIs across multiple platforms thanks to Skia, right? And because you mentioned that compose multi underneath the hood using C code, so, and we know, for example, like the share compilation jank issues that we have on iOS. Have those been solved in Compose? Are those issues also there? Because we know how Flutter is now ditching Skia for even their own, or is it like Compose multi-platform just moving little by little, adopting Skia, maybe in the future might also do something go the route of Flutter?
That's a great question. I don't know the answer, but I I think that the issue you brought up, I don't think that's resolved. I think it's just starting out, so it's in its alpha version. But for my next talk, I will definitely have slides on that.
Just curious, is this a method to create something like native?
Oh man, that's deep. So that's so no. No. I want to answer that in a positive way. I want to answer that in a concise way. So there is a possibility you could go down the route where you could build your whole UI. I don't really recommend that. So in this space, there are different ways to go about doing this. You could build a Flutter app, right? Some companies go about just changing their UI Flutter app. You also use developers, but there, and then you have another option, which is that, well, so there is a library called Redwood that you could use, which is different than building. It's not about React Native. That's good if you have a use case where you have a UI driven, you have a design system defined, and that's one way to do it. I could go into so much details about that. There's another way to do it, which is you have your Android UI code and you got your iOS UI code. For now, I'm just going to call it multi-platform for just shared business logic. And this has been released on iOS for alpha, and it raises questions, which is, I don't have all the answer, which is, what UI component are you going to share? Or do you need to share for your business needs? Everything should be about business needs rather than engineering. So, what problem are you solving? It all starts with that, right? So when I said the second choice I said, which is with Redwood, for example, that started from a business decision. That started to solve a problem, an actual real problem. So, yeah, that's it. I'm going to go off my soapbox. Oh,
All right, that was Mohit, an Android GDE. Well, like we saw in first session when Lucas was talking about a gist of Google I/O, and it was about AI. Well, in the world of Android, it's compose, and compose. My friend Russell over there must have enjoyed his talk. He's all about multi-platform. All right, so in first session, we learned about large screen devices. Now, what if we compress them to something tiny and fit it on our wrist? Let's welcome the speaker on the stage, the amazing GDE Sierra. And she's going to talk about Android wearables.
I'm not. Do I share my slide? I'll probably just use the podium mic. That's fine. Oh. Yeah. Okay, I'll just hold it. Thank you. Not the right shirt for this. I'm gonna share screen. Oh, and then do I put this in? Okay, yeah.
Just mirror it? No?
It's like mirrored now.
I can turn on mirroring. We can just do that. It's fine. I just can't see the time if I do that. Come on, man.
Oh, I can help you with time. Like, at what time do you want to?
Oh, yes. Oh, it's at the bottom. Okay.
So,
What side is this on?
Oh, there it is.
We'll do it. Yeah. All right. Oh, no, I can't get my mouse back. Great. We're going to go without speakerphone. I can't get my mouse back. All right. I'm sad I had to go after Mohit because his presentation was really cool and I was really excited about that. And I've wanted to see that presentation for a while. So I'm very glad I got to see you here. I'm Sierra Bryan, and today we're going to talk about some different parts of Wear OS. A fun fact about me is I don't like wearing watches, let alone smartwatches. And so this probably feels like a really poor choice and topic for me that I continue to talk about at every conference I can get into. And that's because I'm really excited about the potential of finding a reason to wear a watch. I have an Apple Watch, I have a Google Watch, I have a variety of regular watches. But I think my Apple Watch has been dead probably since sometime last year. My Pixel Watch I get locked out of every time I need to turn it on for something because I never use it. Except to test for these sorts of things, and all of my other watches also have dead batteries. So again, an interesting topic, but you're stuck here listening to my exploration on Wear OS. So today we're going to talk about some of the ways we can use health services and Wear OS to build better app experiences. They told me I should talk about Google I/O because we were at Google I/O Extended. So let's talk about the different things that were announced and talked about with Wear OS at Google I/O. So what did we talk about? One, we talked about notifications. Too long didn't read here is that notifications on Wear OS and Android are really, really similar. The only thing that we really care about is that you might have bridge notification, which is going to be on all of your devices, or local, which again are just specific to the Wear device. If you're going down that bridge path, you just want to make sure it's a good user experience across all those devices, and they're not having to dismiss those across different devices in their ecosystem. We talked about watch faces. They have a new watch face format that's no code, and so your designers might be able to design their own watch faces, although it's XML, so I don't know if they're really going to want to. But they do have a nice watch face drag and drop, kind of like the editor inside Android Studio, and so that's another way to do it. They talked about Google Assistant. You can use app actions to jump to specific parts of your Wear OS app, which can be a really good use case for using Google Assistant. And they added some really nice features to the plugin to make it a little bit easier to test those locally versus needing to publish your application to do that. And finally, they spent a long time talking about tiles. So you can guess we're going to be talking about tiles today. Some of the considerations we want to think about when we're building for tiles. First, we're going to design for like a glanceable amount of information. It needs to be the most important things, something that people want quickly, minimal interactions because they're just a single face. Save all of your user interactions to actually guide them into their application where you have a more robust set of UI elements and better interactions for that. We don't want anything that's long-running asynchronous processes that can drain the battery because they're always available, they're always running. And it's just something quick that you want to glance at really fast. Next, we need to, again, optimize for that battery usage. It's going to be running in the background a lot of the time, and so we don't want to drain our user's battery. We want to build with the material guidelines, and so there's a bunch of material components similar across the Android ecosystem that you can use to build out your tiles. We'll look at some later, and those are just going to give them consistency across all their Android tiles and app watch tiles so they know what to do and what to expect from those. And then finally, we want to complement this with the other surfaces. We want to use the right surface for the right reason across Wear. Wear has a lot more surfaces than some of our Android apps, which you put them in the app and they navigate around. Whereas on Wear, we have these tiles, we have actual apps, we have the complications. And so we have all these different places that you can go and look for information. And so we want to use this one for that low-hanging fruit for information that they need quickly and often. And then last is that we just want to keep it simple, which really goes with all of those other points when we're thinking about what we want to do for tiles. Now we're going to talk at a high level about health services. The reason that I always pair these Wear talks with the health services is because, again, I'm trying to figure out what I'm going to build so that I will wear these watches I have. And when I ask people, why are you so excited about your smartwatch? Why do you wear it all the time? Then 90% of the time, the answer for that is something with health. I'm either listening to music while I'm running. I'm taking phone calls while I walk my dog. It's tracking my health at all times. It's tracking my sleep. And so these health services were really interesting to me. I personally don't love any of the health apps out there because I don't like things that yell at me when I don't work out. So I need to build something for me and my use case. So what do you need to know about health services? One, it's a set of powerful algorithms that are built on top of the sensors on the watch. Previously, before health services were introduced, developers had to go directly to those body sensors and the different sensors, take that data directly, and then do their own calculations. This led to inconsistent data across different applications. Those algorithms could be kind of intense. You could get them wrong. And so health services is going to solve a lot of those problems. Those algorithms are already implemented, and they're implemented in a battery efficient way so that you can reliably and safely use them in Wear apps without having to worry about the impact on the user's battery. Can't see the rest of my speaker. So in addition to that, it also gives you that consistency across applications. If everyone is using the same algorithms from health services, then we're going to get the same information from one app to another. So if I'm using my personal app versus someone else's, I can guarantee that that time interval for the amount of time I spend exercising, my heart rate, those are all the same across all these different places. It also is giving us really consistent APIs so that we'll see long term if that's true, but consistent APIs so that you know how to use them in your applications. So when we talk about health services is going to be the entry point into all of these different ways we're able to monitor health for users. And so from that health services, we get to pull out the client, which is going to give us access to the observable data that we have from the sensors. Our health client is going to provide a way to subscribe to health data in the background or foreground. Our health client is going to be broken into 3 different clients underneath that. We have the measure client, the passive monitoring client, and our exercise client. If we look at each one of these individually, our passive monitoring client is going to let us passively monitor without requiring any kind of ongoing workout. It's also going to be expected to run long-term in the background. Next, we have the measure client, which is going to make measurement of health data on a device. It's going to go really quickly for some short period of time because it's going to sample much quicker than the passive monitoring client. And finally, the exercise client, which is going to provide a way to subscribe to health data of a device during an exercise. And so this is going to be all the different exercises that your watch supports. And this is the big focus of the announcements around the health services at Google I/O. It's talking about the new exercise that they're supporting. It was specifically around golf. I'm not a golfer. So today we're going to build a health tile, and we'll be using the health client. We're going to be using Horologist, which is a library a lot like Economies for Wear OS development, and we're going to be using material for tiles. So let's go ahead and get started. So we're going to start by adding a new to an existing health application that monitors heart rate and steps. What does this app do? It's a really simple application. It's going to be built with a composed UI. We're not going to go super far in depth with this one. And that's powered by a view model. For those of you that don't know, it's the same picture that Net just showed. We have that UI sending our actions down. Our view model is going to push state up. underneath that view model is where we're going to have this health repository. And our health repository is going to be what is going to actually manage our health client that we just talked about. So from our UI, we're going to push on the action to start the service. The view model is going to talk directly to that health repository where we're going to have an instance of that health client. That's going to check the capabilities of our device because not all watches will have the same exercise capabilities, and then register the listeners if we have those available for the two things that we're going to monitor, which again is heart rate and steps. Underneath our health repository, we're going to have a data repository, which is just going to be a data store. And so once we measure that, we register that listener, our health repository is going to push that data down to the data store, and our data store is going to push that back up to the view model so that the view model can update our UI. And so we have this really simple application that we can open the watch app, look at our health data whenever we want it, and it's just going to continue to monitor. But now we want to add this tile so it's glanceable, and they don't have to actually open that application. They can just check the tile, keep that open, and check what their heart rate and steps are throughout the day. And so what we're going to do is get started by adding a new passive tile service that's going to extend the suspending tile service. This suspending tile service is what comes from that horologist library. We have the choice here to go directly with the Java APIs from Google around the Wear OS, but those require working with listenable features. And so instead, we can use streams. And so that's what the horologist library is going to supply for us for these tiles, is that we can instead use the suspending tile service instead of having all of these functions that we're going to override and return these things in the future. We can override suspend functions, although they work in really similar ways. So if you feel comfortable using one, you should be able to go back and forth really easily. Once we have that service, we're going to add it to our manifest. We're going to register our new passive tile service. We're going to be able to add a couple of different ways to customize that for our users. So we can add things like an app icon, a label that they'll save in when they add that to their watch face. And so now we're going to jump back to our passive tile service now that we've registered it in our app manifest. And there's 3 functions we're going to override to build our simple tile using health services and these libraries. One is going to be our tile request, and we see that suspend. So this is coming from the suspending tile service. Number 2 is our resource request. Again, a suspend, otherwise it would be a feature. And then finally, we're going to also create a function, layout, which is going to return the actual layout of our tile. So we're going to start from the bottom down, and we're going to get started talking about the layout. Now, I have this really horrible habit where I like to look at something really complicated when I'm getting started. I mean, like, oh my gosh, I can't do this. This is like too much. And that's exactly what I did when I was looking at tiles. I went to some Google samples, I looked at it, and I was like, oh my God, I have to learn a new way to build UI. I just learned Compose. It's too much for me. But what I found is that building layouts for tiles, you'll be able to use a lot of the same mental model as building things for Jetpack Compose. Yes, it has some different names. We're going to use this builder pattern with these different layouts, but we'll be able to think about it in a really similar way of setting things up. So we're going to get started using this edge content layout. And this is going to be one of several different layouts that we can use for tiles from the material library. So we're using this edge content. We're going to actually building a UI pretty similar to the one that's here under edge content, because it gives you that progress bar around the edge, or it gives you a slot for the progress bar around the edge. But there's also a multi-button layout, a primary layout, and a multi-slot layout where you can fill all these in. Here we're already seeing that mental model that we have for both Compose and for tiles. And that these are just slots that we can fill in information, similar to how a lot of the Jetpack Compose APIs are set up. So again, we're getting started with edge layout. And so we're going to be building this UI that has our heart rate and our steps out of our goal for the day. And so this one has 4 different slots. So we have our edge content slot for information that goes around the edge. We have a primary label content. We have a content, which is what's going to go in the middle, and then also that secondary label content at the bottom. So now that we have our edge content and understand the different slots and functions that we can add to it, we can get started by adding our edge content. We're going to get started with a circular progress indicator, which again, you already see those similarities between our builders and compose. We can set our progress to the number of steps. We can add some colors, and then we'll build it. This is one of a lot of different material components that we can use. So again, we're relying really heavily on those patterns defined by material to build our application as well. So we're getting started with the circular progress indicator. But these are some of the other material components that they have. In addition to this, they have some basic components available for you too: text, image, spacer, to use in those different flats, as well as different layout components, more simple, like row and column. So now that we have our circular content, we're just going to work down that list of all the different slots we need to fill out. So we're going to go ahead and set our content, which again is that middle part. So for us, that's just going to be a text. We're going to style it with a typography and again, add a color to it. From there, we can now add our secondary content, secondary label, text content, text again, add our goal and steps. That's going to be the one that goes below it. And then finally, we're going to set that primary label text content. This one, we had both that heart and that text. And so now we're going to use one of those layout elements that are available to us. And so we use the layout element builder.row. We can set some different parameters on that. So this is going to wrap around and expand the height. So similar to building an XML. We're going to set everything there to be aligned vertically in the center so that everything looks really nice. And then inside that, we get the same pattern where we can set that content. From there, we can add all the different layout elements we want in that row. So I have my image, which is going to be my little heart with some height and width set. Then I have a spacer to push those apart so they look really nice. And then finally that text with my heart rate. Wow. Now what you might notice about this is that we're not setting an actual resource ID, and our tile does not have access to the resources in our application. And so instead, I'm just passing in a string image from resource. And this is going to take us to that next function as we work our way up this stack of functions. So here we're going to jump into the resource request. And this is where we're going to map resources from our application to what we're going to show in our tile. So we set our version to our resource version into 1, and we have to add all the different IDs to image mapping. Here we see that string defined again, image from resource, and that's mapped here to an actual drawable for my application. It's just a filled heart icon. And so this allows my tile, when it sees that image from resource string, to come back to the mapping and know what to actually show there. I would just continue to add any IDs to map. If I had multiple UI elements in my multiple image elements in my UI. So now we have our layout, we have our mapping for all of our resources, and we're going to this final function, the tile request. And so from here, the first thing that we're going to do is create our tile timeline. Every tile needs a timeline, and there's a couple different ways that you can do this. My application is going to look the same no matter what time of day it is. It's always going to be the same, although it's really cool for it to change color depending on the time of day. And I'd be able to do it from this tile timeline, from this timeline builder. So I have a single timeline, and so I just have this single timeline with this layout, but I'm able to set multiple timelines here that do have some kind of period of validity. So a classic example is building something for your calendar. There you would have different timelines depending on each different meeting on your calendar, and the watch tile is always going to show the one with the shortest amount of validity time coming up. I'm just going to set my root element to this layout function I already built. And from there, I'm going to take that timeline, set it in my tile builder, and build that. And that's going to be the UI that it shows. The other thing that we have here is this freshness interval, which is commented out for me. But this is going to let you tell the watch OS, Wear OS, how long until your tile is out of date or stale, and it should try to update. We want to keep that at least over 1 minute. But I'm able to use the data available so that I don't have to do this. So now we've talked about all of this tile information, but we haven't actually talked about the health app at all. So let's talk about where the passive data that we were collecting comes in. So we're able to override on create, and we have that passive data repository. We talked about the way our application was set up. And so we can pull out of that repository the latest heart rate, the latest steps, combine those into a UI state that we can then use in our tile app. Once we do that, we're going to pass in that latest tile to actually set the steps and the heart rate on that application. Now, out of the box, this won't update, although we have a state flow that's coming in. And so we have two different ways that we can potentially update that I experimented with. First is that anytime that data changes, we can just request the tile service to actually update our tile. And we can do this anywhere in our application by just calling the tile service, get updater, request update for that particular tile service. The other thing that I tried to do is that we have modifiers, again, just like when we're thinking about Jetpack Compose, and those are gonna let us do things like add interaction to those different slots in our tile. And so the other thing that we could do is set a modifier. I set one on the content in that middle view, and that allows me to make that text clickable. And when I use that, it would automatically load and again, request an update. So instead of automatically updating, when the user pulls it over, they can just tap it, and the UI would be updated with the latest data. There are only two actions that you can have in a tile. Is one, load action, that's what we're doing here, where we're going to update that data, or opening a different activity. And so when you run into those situations where you have too much information and it needs to be a little bit more interactive for your user, you're able instead to direct them into your Where app and actually open that activity instead of cram it all into the tiles, which is meant to be kept simple. So we've now used all these Java APIs, but what about Glance for tiles? If you don't know, Glance is going to be a library that's built with Jetpack Compose for widgets, and they introduced a tile, Glance for tiles as well. So I also went ahead and experimented with this. For this case, we're going to go ahead and instead of overriding that suspending tile service, we can override the Glance tile service. Once we do that, we need to override a function content where we have both @composable and @glance composable. And then it's just a straight composable with very limited UI components. So I start with a box, and then I added my column, and instead of having a modifier, we have a glance modifier, but we have a lot of the same things. So I could set my vertical alignment, horizontal alignment, and build about the same UI, adding a row with my image, a spacer, a text, just like we did with the Builder and Java APIs. Add my two texts, and then I am pretty much good to go. I could not ever get the circular one to work, and it was not built in, and so I did not give myself enough time to figure it out. But with just this, I get pretty close to the same thing, and I have all of the same data. I have the step count, I have the heart rate. So what are our considerations for Glance? One, the tiles with the Java APIs is still the recommended way to do it. Glance for tiles is still in alpha, and you can feel it. When I ran into any kind of problems with this, there's not a lot of resources or examples, so you have to be ready to debug yourself. There's a blog post introducing it and giving you about the 10 different composables that are available. I used about half of them. And I actually looked on GitHub for anything that was extending the Glance tile service, and there are none. So nothing to here, and just some basic examples from Google about how to potentially use this. And so that makes it really hard to debug if anything comes up and it's not working for you. And so right now, I'd probably still recommend using that builder pattern with the Java APIs if you're thinking about building a Where tile. And so with that, thank you so much. You can find me online, cerobrien.dev. My email and LinkedIn are there if you want to get in touch. Again, thank you to the organizers for hosting me.
I was wondering about the home screen widgets. Is Glance supposed to kind of bridge the watch and home screen widgets?
Yes. Yeah. Yeah.
So, but it's I mean, the Glance tile that you just wrote, would we be able to see that?
On a widget?
Yeah.
I don't think so. It would be a different library. This is like separately Glance tiles, and you'd need the different Glance libraries for that. It's also not interoperable with regular Compose, so it's completely separate. It goes to that tile service anyways. So if you build a Wear OS with Compose, it also doesn't work with Glance with Compose.
The main issue with tiles is that they, you code it in your application, but it's rendered on the CGI application.
Yeah. Yeah.
So it's a process communication going on. So that's why there's a special handling. So it doesn't surprise me that the Glance Compose is probably not very compatible with the regular.
No, it's not.
It looks the same.
It does.
Some of the same mechanisms maybe behind it, but basically you render something in the background, it gets parceled.
Yep.
Back to the CGI.
Yeah, I worked with the remote view.
Mm-hmm.
Yeah. They're the same with the other questions?
I've got a question. So what advice do you have for an engineer who is working on a code base which has been for a long time, but they are trying to migrate it to a Wear OS, or probably trying to create a proof of concept? Do you have any advice on where to get started? What are the first steps? What are the things that you need to keep in mind?
I think the number one advice is like deciding what goes in your Wear OS or your Wear app. They're not meant to be like as fully functional as an application. And so thinking about like the small convenience actions that you can add into a Wear OS that they can do really quickly, because you have to like hold your arm like this and interact with this tiny screen. And so like really nailing down like what is the use case for doing this versus just building a Wear app to build a Wear app. Yeah. I'm still trying to find mine.
Just to make sure when I was on stage that I knew my phone was not going to any. It's kind of. I haven't seen sound check. I haven't seen that, but I think like you can use the watch. Right? The phone watch doesn't have a speaker calling. Now they're sold separately. It's interesting. Thank you so much. Yeah.
Thank you.
So, okay, good. There was an original plan to have things that give closing remarks, but we probably didn't have closing remarks. We're all set for this. All of our speakers.